Welcome to the deep dive. Today we're digging into something crucial for anyone eyeing an EV, the battery technology that's just around the corner.
We've got this report full of future battery tech, and we want to break down what it really means for you, the driver.
Exactly. Forget the jargon for a minute. We're talking longer trips between charges, way faster top-ups, and, importantly, safer cars.
Yeah, because, look, lithium-ion's great. It powers almost everything now, but it has limits, right? Range
Yeah.
anxiety is real.
Oh, yeah. And waiting for a charge can be a pain. Plus, you hear about safety concerns sometimes with the liquid stuff inside.
Precisely, and that's why all this new research is so important. Plus, EV sales are booming 17 million last year. That demand is pushing innovation hard.
Okay, so let's jump in. First big one, solid-state batteries. Feels like everyone's talking about these. What's the core idea?
Well, it's basically swapping out that liquid electrolyte we just mentioned for a solid material. Could be ceramic, glass, maybe even a polymer.
And doing that lets the lithium ions move faster.
Sort of, yeah. It enables different ways for them to move, potentially leading to big benefits.
Okay, benefits for me driving the car.
Big ones.
Yeah.
First, energy density. Potentially double what we have now. Companies like LG, Samsung, they're aiming high. Honda's talking like 620 miles on a charge.
620 miles, that really changes the game for road trips.
Absolutely.
Yeah.
And safety gets a serious upgrade. No flammable liquid means much lower fire risk. Peace of mind,
Definitely. What about charging? That's a big one for me.
Could be way faster. Some are talking under 15 minutes. Toyota even said minutes, not hours. Honda's goal, 10 minutes to get you from low to 80%.
10 minutes. Okay, that fits into anyone's day.
Right. Plus, they might last longer, too.
Yeah.
Fewer degradation issues mean maybe way more recharge cycles, fewer replacements.
So longer life works better in hot and cold weather, too.
That's the potential, yeah. Wider operating temperature.
Sounds almost too good to be true. What are the hurdles?
Cost is a big one, initially. Getting production scaled up affordably. And there are technical things like resistance at the interfaces inside.
Yeah.
Maybe those dendrite things in some design.
Dendrites, little spikes.
Yeah. Tiny metallic growth that can cause problems.
Yeah.
But they're actively working on solving these things.
So when might we actually see these?
The target seems to be late 2020s, maybe early 2030s. Toyota's being really ambitious, shooting for 2027.
Wow.
Yeah, and Samsung, BYD, Nissan, Hyundai, Panasonic,
Yeah.
lots of big names are racing towards it. Solid power, QuantumScape 2. It's a busy field.
Okay, something to watch for, definitely. What about lithium metal batteries, another range booster?
That's the idea. Using actual lithium metal for the anode part could boost energy density significantly, maybe 50% or more. Again, think longer drives.
But those dendrites again.
Yep, that's the main challenge here too. But they're developing special separators, coatings, optimizing the electrolyte. Solid state helps here too to manage them.
So tackling the problem head on, who's big in this space?
LG's involved, Solid Power is looking at it, Amprius is doing interesting things, maybe more with silicon, but showing huge potential range numbers.
Okay, silicon. Let's talk about silicon anodes. That's about improving current tech, right?
Sort of, yeah. Silicon can theoretically hold like 10 times more lithium than the graphite used now.
10 times. So lighter batteries?
Potentially thinner, lighter batteries, yeah. But the big problem is silicon swells up massively when it charges, like 300 to 400%.
Whoa. Okay. That sounds destructive.
It can be. So the trick is managing that expansion. They're using silicon-carbon composites, tiny nanostructures, special coatings, porous designs, lots of clever engineering.
Companies like Cyrilla, Innovate, Amprius again.
Exactly. Leyden Jar in Europe has a 100% silicon anode. They say increases density by 50%. Lots happening there.
What about moving beyond lithium entirely? Any other options?
Oh, yeah. Sodium ion's getting a lot of attention. Sodium's everywhere, much cheaper than lithium.
Cheaper is good. Any downsides?
Generally lower energy density for now, so maybe heavier for the same range. But they can be safer, handle temperatures well, potentially charge fast. CATL and BYD are pushing this hard.
Interesting. Anything else?
Magnesium ion looks promising on paper, abundant, safe, high capacity, but it's much earlier stage. Lots of chemistry challenges. Zinc air too, very high theoretical energy, uses air. But rechargeability is a huge hurdle for EVs.
Okay, so lots of chemistry angles. What about just building the battery differently? Structural batteries?
Yeah, integrating the battery into the car's structure. Carbon fiber tarts that also store energy. Could save a lot of weight, boost efficiency.
Like the car's chassis is the battery?
Kinda. Then there's a cell-to-pack, or cell-to-body, getting rid of the intermediate module casings, packing cells directly. More energy in the same space, less weight.
So more range again. Tesla and BYD are doing
They're
this?
leading the charge, yeah. It simplifies things, but also makes repairs and thermal management trickier.
Right, can't forget the brains, BMS and
Right.
cooling.
Absolutely critical. The battery management system is the guardian, monitors everything, keeps it safe, balances cells, getting smarter with AI now.
And keeping it cool or warm.
Thermal management, yeah.
Yeah.
Keeping the battery in its happy temperature zone is vital for performance, safety, and especially lifespan. Liquid cooling is common, but they're always refining it.
So lots of innovation happening across the board then.
Definitely. It's not just one magic bullet. It's chemistry, materials, design, software, all pushing forward.
The bottom line for us drivers seems pretty exciting. Potentially way more range, much faster charging, safer cars, maybe even cheaper ones down the line.
That's the goal. It's a
Amen.
really dynamic space right now.
So as we wrap up, with solid state, lithium metal, silicon, sodium, new designs,
Hmm.
which of these do you think will actually hit the mainstream first and make the biggest difference to our daily driving? Something to think about.